Hello, my dear students. Happy morning to all. Hope you people are doing well and preparing very well for your competitive examinations. Soon it's approaching very nearer here. Very few chapters over there. You just concentrate over on the chapters. In this chapter already I told you are having one question. Till now we have seen about a AC circuit. In this AC circuit we are going to concentrate about LCR circuit, that is about inductance, capacitance and resistance circuits over there. See, for either you may have a AC circuit, that was we have seen a previous session over there, and this one, in this case, this one or an LCR circuit or AC circuit, one questions will be there for your examination. Hope you are understanding well. If you like this video, you just subscribe the channels and pass the comments on the comment section so that we can discuss over through a comment section. If you are having any doubt, I will send you the doubts as a this one shorts so that you can understand better. Subscribe the channel for your updates. Okay, we'll start the session on LCR circuits in additions. First problem on the session is about see here about instantaneous voltage and current they have given. What do you mean by instantaneous voltage and instantaneous current? So instantaneous voltage and current is there at the particular instant of time. So at a particular instant, what is that potential and what is the current in a circuit? In a AC circuit, that is gives about the instantaneous current. Okay, we'll see about the first problem here. First problem is a old question paper problem. See, in a AC circuit, they have given about instantaneous EMF, voltage and current are given by, they have given E and I. See, from this one you can understand here. See, I just tell you, this one is about E. Here is potential the same one. So this one from here, V is equal to V naught sin omega t. See, from here V naught is equal to 100 is there. Similarly from here I naught. So I naught here is V naught is about a peak voltage, I naught is about a peak current here. Peak current value also they have given. This is sin 30t and this one here is sin 30t minus pi by 2. So the phase difference here is pi is equal to pi by 4. So this one is pi by 4. So the phase difference here is pi by 4. In one cycle of AC, see what they have given. You just see one cycle of AC, the average power consumed by the circuit and wattless current. See, let me tell you what you mean by average current and wattless current. Current, average of average power and wattless current. See, let me tell you here. In this case, first one is about average power. So average power here is, I just mentioned the formula, P is equal to, see, or even you can mention here P average here is VRMS and IRMS, VRMS, IRMS, and the phase difference between that one, that is cos theta here. VRMS, hope you know this one, V naught divided by root 2 here. IRMS, again this one here is I naught divided by root 2 and a cos of pi value, that is 45 degree here. That is the phase difference, already I have mentioned this one. So V naught value already we mentioned here, that is 1000 divided by root 2 here, into I naught value here is 20 divided by root 2 again. Cos of 45, that is again the same 1 divided by root 2 here. So root 2 into root 2, that is 2 here. See, from this one what we have mentioned here is 2 root 2 into, so what you got here is 2000. From this one if you cancel here, so what you are having here is 1000 divided by root 2, that is about power P average here. So what we got here is P average value we got. See, from this one only you can understand here P average value, this one. So answer you can confirm this one from his first option is the answer. I just tell you what you mean by wattless. So wattless current, see, wattless current, remember the formula, they may frequently asking about this one. Wattless current here is IRMS. So this is about the current, IRMS sine of angle, sine theta. IRMS value already we know this one, I naught divided by root 2 here, I naught divided by root 2 into sine of 45 degree. So again I naught value what they have given here is 20 divided by root 2 into sine 45 again, that is 1 by root 2 here. So root 2 into root 2 here is 2. So 20 divided by 2, what you are getting here is 10. So 10 ampere is the current. So answer in this case. To the next problem. So this one, before going to that, we have to mention what are the data has been given so that this questions will be little easier. and inductance. So inductance value they have given. So here is inductance means L value. See, I just mentioned here inductance here is L 0.2 Henry, and the resistance they have given, that is R 100 ohm, are connected to an AC. Potential they have given, that is V, or even you can mention like E here, E 180 volt, and the frequency they have given, that is 50 hertz. So what they are asking here is the current in the circuit. So I value they are asking here. So I is equal to what? See this one. See, according to Ohm's law, hope you know about this one. V is equal to I into R. See, from here current I is equal to V divided by R. Already I told about this one. In case of DC we can mention this one as resistance. In case of AC we can mention this one as impedance. So I just mentioned here E is equal to E, that is about a potential here, E divided by impedance. We can mention this one Z. In case of inductor and resistor circuit, how you can mention the impedance here is E divided by square root of this one here is R square plus XL square. So XL is nothing but XL is equal to L into omega here. So omega value already you know this one, that is 2 pi F frequency. So frequency you can know about this one. See, from here XL L omega, I just substitute the values here. E divided by square root of R square plus L square omega square. Now substitute all the values here. So this one E value here is 180 volt divided by R value, what they have given, the R value here is 100. So 100 square plus L value here. L value is about inductor, that is about 0.2 into omega here is 2 pi. Frequency what they have given, that is 50 here. Now 50 if you multiply with this one, that is whole square. So this is about whole divided by. Now you just simplify this equation. So simplify it, and what you are getting, that answer here is 1.52 ampere. So current in this case, so simplification you just do work it out. If you couldn't find the answer, you just mention this one in a comment section. See, if you multiply with this one and this one, you can get a 1 here. So 5 into 0.2 here is 1. You will get 1 into 2 into 2 pi and make it a square. Add this one and simplify it. You can get the answer here is 1.52 ampere here. So answer in this case. Next problem here. See this one, what they're asking here is the frequency for which a 5 microfarad capacitor. So they have given about capacitor value and as a reactance. So that is capacitive reactance. See this one, that is Xc. Xc is about capacitive reactance, and XL about inductive reactance. See this one, the XL is about inductive reactance, inductive reactance, and Xc is about capacitive, capacitive, same reactance here. See what they have given, reactance in this case Xc value they have given, that is about the resistance 1 by 1000 ohm is given by. They are asking about frequency. See, already we have seen XL value here is L omega. Similar here, but here Xc value here is 1 divided by C omega here. Now see, Xc value they have given and C value they have given. They are asking about frequency. See, frequency in this case I just substitute here. Xc is equal to 1 divided by C into 2 pi F. F is about frequency here. So F is equal to 1 divided by C into 2 pi into Xc here. Now all the value, just substitute all the values. 1 divided by C value, what we got here is 5 microfarad, that is 10 power minus 6 farad into 2 pi here, and this one Xc value, see here Xc value what they have given here is 1 divided by 1000. So that is 1 divided by 1000 here. So 1 divided by 1000 here is, this will become 1000 will come over here, and whole divided by 5 into 2, and pi here 2 pi, again I just mentioned here pi here, into 10 power minus 6. 10 power minus 6 will come over here. So this one what you are going to have here is 10 power plus 6. See, from this one, so 10,000 over here, and this one here is 10 power 6 over there, and here is 5 into 2 pi over here. Now you just cancel this one. So from this, see here, 5 into 2 here is 10. One cyber will be cancelled here. So 100 into 10 power 6 minus 6 means micro, plus 6 means mega. Mega and divided by pi here, mega hertz. This is about frequency. So F here is 100 by pi megahertz. So answer in this case. The next question. See here, the natural frequency of LC circuit, that is 125 kilohertz. The capacitor is, see in the LC circuit, capacitor has been replaced by another capacitor with dielectric medium. So with the constant they have given, in that case the frequency is decreased by 25. See, after introducing 25 has been decreased. So in that case, after introducing a dielectric, the frequency here is 100 kilohertz. So the value of K is what? See this one I just mentioned here. First case, what you mean by natural frequency? See in that case I just mentioned here, natural frequency. Natural frequency F is equal to 1 divided by 2 pi into square root of L into C. So this is about the natural frequency formula here, and what they have given, that value here is 125 kilohertz. This is equation number 1. Okay, next one. Second equation here is after introducing. So this one, after introducing, I just mentioned, after introducing K, dielectric material with dielectric constant K, that frequency here is, so that time frequency value here is, I just mentioned as F dash equal to 1 divided by 2 pi. This is formula here is, after introducing dielectric here is, here a KLC will be there. That value 25 has been reduced. So here is 100 kilohertz. So this is equation number 2. See, from equation 1 and 2, or 1 divided by 2, you just mentioned here. 1 divided by 2 here is 1 divided by 2 pi into root of LC here. And the second equation here is 1 divided by 2 pi into square root of KLC. And the first one here is 125 here, and second one here is 100. See this one. See here, 2 pi will be cancelled here. So that is 1 divided by, this is only root LC is there. This one I just mentioned as root K into root LC, so that you can easily cancel over here. This one for the fifth table you just cancel this one. This is 25 time, and this one here is, or even uh, fifth table, this one here is 20. Again you can cancel it for the fifth table. So what you are having here is 5 divided by 4. So this one will be cancelled here. So root K will be equal to 5 by 4. Make a square of this equation. See, from here I just mentioned this is equation number 3. Square equation 3, that is K is equal to 5 square here is 25, 4 square is 16. So 25 by 16 here is, you can mention this one. So answer in this case 1 times, you just divided this one again, you just cancel it. So you are going to have here is K is equal to 1.56. So answer in this case. The next problem, this is quite interesting. See, it's very easy problem here. An alternating EMF E equal to E naught sin omega t. So E naught, or even V equal to V naught sin omega t. V naught value we know, omega value we know, is applied across a capacitors of capacitance. So C value they have given 1 divided by 0.628. So simple, this one divided by 2 pi. That's all. See, the pi here is 3.14. 2 pi here is 0.628 into, so 3.14, 6.28, that's all difference. This is little easy. 1 divided by 0.628 microfarad, that will become 10 power minus 5 farad. That's all difference. The capacitive reactance and the peak value. So capacitive reactance and peak value they are asking here. Capacitive reactance in this case, this is about XC here, and the peak current here is I naught. That's what they are asking here. See this one, first one XC, that one will be equal to, what is XC here? 1 divided by omega C, or C omega. Hope you know this one. XL equal to L omega, and XC is equal to C omega. That's all. That is 1 divided by C omega. That's only difference here. This is about XC. So from this one, see here omega value from here. So you can mention, I just mentioned here, E is equal to E naught sin omega t here. See from this omega is equal to this one. Omega here is 100 pi. Right. Now you just substitute here 1 divided by omega here is 100 pi, and the C value what they have given, that is 1 divided by 0.628 into 10 power minus 6 farad. See here, so what I'm going to mention here is 1 divided by 100. So this one I just mentioned separately, 1 divided by 100 into, here is 10 power minus 6, this will become 10 power plus 6 over here. 1 divided by 0.326, what you can mention here. So here 1 divided by here is this one 6.28. So 6.28, see here, divided by 10. So that is 0.268. Hope you can understand here, and 10 pi is there. So 6.28 divided by 10 here is what you can mention here, that is nothing but 0.268. So this one, this 10 will be cancelled here. So this is about 10 power 5, and here is 100 is there, and here is pi is there. 6.28, what you can mention here, this one 3.14 into 2, that is you can mention this one as 2 pi. That's all. So pi will be cancelled here. This 2 cyber will be cancelled over here. So what you are having here is 10 cube into 2. That is 2000. 2000 ohm. See here. This is 2000 here. 2000 ohm. This is about XC. So one answer you got. Next one, I naught. See what they are asking, I naught value. See, according to Ohm's law, V is equal to I into R. So I is equal to V divided by R. See from this one, in this case in a AC circuit, this is about E here, E divided by R here is X into C. Now you just substitute the values here. This one already E value what they have given, that is E naught. See, this is I naught means this is E naught. So E naught value here is 200 divided by XC value, already we got this one, that is X 2000. So this will be cancelled over here, that is 1 divided by 10. So here is 10 power minus 1 ampere. So answer in this case for I naught peak current here is 10 power minus 1, and capacitive reactance here is 2000 ohms. So answer here is this one. This is little important, and even old question paper problem also. See here, I just tell you two methods. Which one you feel it's easy, you just follow. This one, this is about LCR circuit, R value given, impedance Z value given. See, voltage and current they have given. In that case, then the phase difference between the current and voltage. So angle between current and voltage value they are asking here. Now this one, in case of LCR circuit, I just mentioned about the formula here. In LCR circuit, in case of LCR circuit, this one, the formula in that case for phase angle here is, I just mentioned as tan of pi will be equal to, see here, x divided by, this is about the inductor. So here from this one, this is x value here is square root of z square minus r square whole divided by r. So here z value what they have given here is 20 square minus r square here is 10 square here, square root whole divided by r value is again 10 here. See, 20 square here is 400, 10 square here is again 100 here. So from this one whole divided by 10, this one you just take a root over here. So this is about 300 square root whole divided by 10. So what you can mention here is, see this one, so this is tan pi, right? Tan pi is equal to, you can mention like a 3 into 100 square root. and whole divided by 10. So this one here is root 3 into 10 divided by 10 here. So 10 will be cancelled. So what you are having here is root 3. See, from this one, pi is equal to tan inverse of root 3. So that one here is tan inverse of root 3 here is tan inverse of tan pi by 3, that is tan 60. So answer in this case pi by 3, or else you can mention as 60 degree. So this is answer here is 60 degree. Okay, now see, let me tell you another method over here. This one, see, in this another method here is similar here. Cos pi value here is so this one, this is another method, r by z, simple one. R value, what is that? R value 10. Z value here is 20, so that is 1 by 2 here. See, from this one, pi is equal to cos inverse of 1 by 2, that is cos 60. So answer in this case, the second method also this one. Which one you feel is better, you can follow. So both are similar. Here is a resistance of 10 ohm, a capacitor 0.1 microfarad, and an inductance 2 millihenry are connected in series. See, all the things in a LCR circuit here. See, this one L, C and R circuit, which are connected in series with a source of an alternating EMF. So alternating potential with a variable frequency. So at what a maximum frequency the current flow will be there. That's what they are asking here in this questions. So here I just mentioned the frequency for in case of maximum current flow. That formula here is F is equal to 1 divided by 2 pi into square root of L into C. So this one, in this case, 2 pi into square root of L into C here. Now in that case, you just substitute all the values over here. 1 divided by this one, 2 pi into, see, in this case, see, this is about the resistance over here, R value, capacitance value, that is C here, and inductance value L here. See, from this one, square root of L value here is 2 into 10 power minus 6, and the capacitor value here is 0.1 micro, means 10 power minus 6. See, I'm sorry, this is 2 millihenry, that means this is minus 3 here. See, from this one, what I'm going to mention here is 1 divided by 2 pi into square root of 2 into zero point 0.1 here is 0.2 into 10 power minus 6, 10 power minus 6 and 10 power minus 3. If you add together, this is 10 power minus 9 here. Now from this one, 1 divided by 2 pi into square root of 2 into 10 power minus 10. Now from this one, see, from here, 1 divided by 2 pi into root 2, 10 power minus 10, root here is 10 power minus 5. See, from this one, this is 10 power plus 5 over here, from denominator to numerator. 2 into pi here is 3.14 into 1.414, root 2 value. Now you just substitute in this case. So now if you are substituting here, what you are going to have, that answer in this case here is, see, 10 power 5 means 5 cyber over here, and whole divided by, so 8 point, so if you multiply over here, so what you are going to have here is 8.88. Now once you are going to divide this one, so what you are going to have here is 11,261 hertz, or what you can mention here is 11.261 kilohertz. So answer in this case, problem here is the potential difference across resistance, capacitance and inductance are. See, potential difference across this one, what they are given here is resistance here, resistance value I just mentioned here, VR. Next one is about capacitance, another one is about inductance. See, this one, suppose this is about the potential, they are given like a V over here. First one is about resistance, another one is about capacitance, another one is about inductance. So this is about the potential difference across capacitance, resistance and inductance. That one here is VL So this one you can mention like this VL here, and this is VC, and this one here is potential across VR. Right. Okay. Now in this one, what they are asking here is power factor. Power factor here is, you can mention this one power factor. Power factor cos pi is equal to R divided by Z. Or even you can mention this one, in case of power factor, this is about the resistance. You just cancel it so that you can get this one VR divided by V, and VR, this is about potential difference across the resistance over here, and this is V formula. This is about the general formula here. This one here is VR square plus VL minus VC the whole square. Now in this one you just substitute all the values here. VR value here is 80 divided by this one here is 80 here, and a square root of 80 square plus VL value here is 100 minus, and VC value here is 40 to the whole square. Now substitute this value 80 divided by, and a square root of this one here is 80 square plus 100 minus 40 here is 60 square. So this one 640, 6004 here. I just mentioned this one, the value over here. This one here is 80 divided by square root of 6400 plus this one value here is 3600. So from this one 80 divided by, so what you are going to have here is this one value is about 10,000 over here. So from here 80 divided by 100 here. So what you are going to have here is 0.8. So power factor in this case, answer here is 0.8. Now here in this question, see the following series LCR circuit, this one inductance, capacitor and reactance circuit, when driven by EMF. So EMF source of angular frequency here is 70 kilo ohm per second. The circuit effectively behaves like, see this circuit is effective means it depends on which value, so it will be behaves like whether it is a inductive reactance or even a capacitive reactance. For in that case I just mention as inductive reactance. Inductive reactance you can mention like XL. XL is equal to L omega here. This one L value here is 100 C here. This is about inductor and this is about capacitor, and this one here is about resistance. In this LCR circuit, inductive value here is 100 microhenry. Micro means 10 power minus 6. Omega what they have given here is 70 kilo. 70 into 10 power 3 radian. See from this one you can cancel it. So this is 10 power minus 3 here, and 70 into 100, that is 7000 into 10 power minus 3. So what you are having here is 7 ohm. So in that case inductive reactant here is XL. Next one is capacitive reactance. See here capacitive reactance. So that is about XC here. XC is 1 divided by C omega. So this one divided by capacitor value what they have given 1 microfarad. So 1 into 10 power minus 6, and omega value here is 70 into 10 cube. So what you are going to have, this is 10 cube here. So this one if you cancel 10 power minus 3, 10 power minus 3, this one in numerator this will become 10 power plus 3 here. 10 power plus 3 divided by 70. So one cipher will be cancelled here. So what you are going to have here is, see 100 divided by what you are having here is 7. So 100 divided by 7, that will become approximately 14 one times yeah, divide 0.2 ohm. So from this one, see here XC which is greater than XL. So that what is happening here is this will be reactions like a capacitive reactance. So in this case, see this one capacitive reactance means these two are capacitive reactance. So this one in this case what you are going to have, that answer here is this one. The next problem here, when an inductor L and a resistance R in series are connected across a potential 12 volt and 50 Hz supply. See this one I just draw and show you here. See, one is about inductor. So this is about inductor. Another one is about resistor. So this one like a resistance over here. Both are connected across a potential. So I just mentioned as a potential. That is about the battery potential. How much they have given the potential here is 12 volt potential and 50 hertz of frequency. Now this is about inductor here and this one is about resistance, and the current flow here is, see this one, this is about the electron flow will be there. So current flow along this direction, what they have given the current flow here is, current is 0.5 ampere. Now in this case the current differ in the phase from applied voltage. So pi value they have given, pi here is pi by 3 phase difference. Calculate R value. They are asking about to find R. See, according to Ohm's law, hope you know about this one, V is equal to I R. See, from this one R is equal to V divided by I. Now this one, in case of AC circuit, how you can mention here is, this is about impedance over here. Impedance Z is equal to V RMS divided by I RMS. Now this one, in case of AC circuit, we can mention this one according to this VRMS value. See here what they have given, the potential here is 12 volt of potential and the current here is 0.5 ampere. See, from this one, see, already they have given in this case 12 volt potential and 0.5 ampere. From this case what you are having here is 0.5 is nothing but 1 by 2, that is about 24 ohm, that is impedance, or even we can mention in case of resistance here. Now power factor, already I told this one, power factor in the previous problem you can see here, power factor, that is cos pi. See, power factor cos pi is equal to R divided by S. See, what they are asking in this one, R value. So R is equal to Z into cos pi here. Pi value already they have given, and even Z value we found, that is 24 into cos of pi value here is pi by 3, that is 60. Cos 60 here is 1 by 2. So 24 into 1 by 2. So what you are having here is 12 ohm. So in this case answer here is 12 ohm. That's all. This is the answer here. And thank you so much for your patient listening. If you found this helpful, don't forget to like, share and comment, and subscribe the channels for more videos like this. See you soon in the next chapter on waves. See, waves, you are having two questions for your NEET as well as your EAMCET examinations. Next presentation will be little more concentrate on the waves. Till now we have seen AC circuit and LCR circuit. Even all the previous year questions were discussed, maximum we concentrate over there. We'll see on the next video on waves. Thank you all.